can hear everybody well. We had so far some problems with the voice of the video, if it should be shared, but Vittorio told that he can share it and it will work.
Yeah.
The floor is to Lucia. Unfortunately, I have nothing about Lucia. So probably before starting your video, then introduce yourself and what you are doing.
Sure, thank you very much. Good afternoon, I'm Lucia Botti. I'm a researcher at the Interdepartment Research Center on Security and Safety of the University of Modena and Reggio Emilia in Italy. And we are about to see the result of an investigation that we have together with my colleagues. We have developed aimed at analyzing both the economic and environmental impact of a sustainable product, construction material that we have developed. And we have developed it from the reuse of the foundry sands of an Italian automotive company. So if we will have more minutes after the presentation, I will be more than happy to give you more insights about the context in which this research was developed. So I think we can start with the presentation. If Vittorio could start the video.
Okay, I can start the video. The idea of your paper was
92, or if you want, I can try to share.
Do you want to try? If you want to try, yeah.
I can try.
Try, please.
Okay, so let's see. Because I don't see the button to start sharing. Well, I actually see one button, but it doesn't provide any action.
Okay.
Give me the control of the screen.
You see
the right up-hand corner, you can see a small arrow which is pointing upwards.
Yeah,
and it
but
should share your screen. So first you have to put your presentation or video to the screen and then to share it.
Yeah, this is what I'm trying, but I see the button with the arrow, but when I click on it, nothing. Well, it opens a black window.
Black window, and you see a loading.
No loading, nothing.
Anyway, don't worry.
Okay, Vittorio, we are wasting time, so better start it, please.
Don't worry, Lucia, don't worry.
Thank you very much.
Abdel Razak, I see you on the screen. You are going to present tomorrow. In the afternoon. Yes, in the afternoon. The next session will be meet with your presentation. Okay, you are switched off, but never mind. Yes.
Can you see my screen?
Yeah.
Yes.
Okay.
That's the video.
Okay.
My name is Lucia Botti.
Can you hear?
Yes, thank you very much.
Perfect. Let's go.
I'm a researcher at the Interdepartment Research Center on Security and Safety of the University of Modena and Reggio Emilia. And today I'm going to show you the results of an investigation that, together with my colleagues, Professor Marco Berbonzoni and Professor Riccardo Melloni, we have developed, aiming to analyze the economic and environmental impacts of a sustainable construction material, which is an innovative green mortar obtained from the reuse of the foundry sands of an Italian automotive company. So the study started with the aim to realize a sustainable product obtained from the reuse and the valorization of wastage left over of a manufacturing process. So today, during my intervention, I'm going to show you the characteristics of the green mortar that we have developed and that we propose as a cement aggregate replacement. So we're going to see the results of the life cycle assessment of the product and the cost-benefit analysis for the production process. So as we will see, the results that we have obtained confirm that the adoption of a circular economy based management for the foundry sands would allow both economic and environmental benefits for all the actors involved in the supply chain of the green mortar. let me explain you why we focused on the development of a green mortar for construction and how we started this research. So, international data on the use of primary natural resources in construction revealed that we expect consumption of these materials to increase by 4 times within 2050. And this exploitation is causing the overproduction of solid waste materials. But however, the increasing demand for new products is accelerating this trend, and the demand for concrete has rapidly increased in the last year. So specifically, the over-extraction of the sands and the lowering of riverbeds are causing the reduction of the groundwater table and the coastal erosion. So in response to these phenomena, local governments are imposing restrictions to sand extraction. And this determined a significant increase in the price for primary construction materials. So in 2018, just to give you some numbers, the global consumption of concrete was approximately 4 billion tons. So in this context, the need for sustainable concrete is a global issue that is reaching the attention of the global construction industry. So at the same time, we are witnessing the diffusion of the culture of environmental sustainability in response to the extreme climate change that is affecting urbanized areas all over the world. So today, we also know that economic growth is possible and environmentally sustainable when we use natural resources in a limited way. So the challenge of sustainable development is to satisfy the requirements of modern programs with no impact on the resources for the future generation. This is also the definition of sustainable development. So in this context, governments, social systems are promoting the adoption of sustainable policies for waste management. So for example, the European Commission has adopted a new circular economy action plan aiming to promote the adoption of sustainable approach, along the entire life cycle of the product. And the action plan promotes the switch from a linear economy business model based on the consumption of natural resources and the disposal of waste materials to a circular economy based model, which regenerates the natural systems by keeping materials and products in use and designs waste and pollution out of the system. So the use of solid waste materials to produce sustainable building materials, for example, the mortar is one of the multiple challenges of emerging sustainable construction industry. And furthermore, the rising cost of sand and of concrete is increasing the prices of the buildings and constructions in the last decade. So the reuse and the recovery of industrial solid waste materials, for example, the downstream products of manufacturing processes, for the development of sustainable building materials offer a valid support for problems associated with the final disposal of industrial waste. So in 2009, 2 Italian companies, one leader in the automotive industry is a luxury sports car manufacturer, and one leader in the production of chemical products for construction, with the support of our research team from the University of Modena and Reggio Emilia, developed the green mortar, so sustainable building material obtained from the downstream foundry sands of the automotive manufacturing processes that occur in the car manufacturer involved in the study. So the green mortar that we have investigated in this study was developed in the laboratory of the chemical producer, and the foundry sands adopted in the green mortar were from the casting mold wastes of the Italian luxury sports car manufacturers. So different variants for this mortar were tested in the last year in laboratory prior to the present research, because we aim to define the optimal composition of the mixture that ensure good bending and compressive strength. So in this table, in this picture, you can see the composition of the green mortar that we adopted, that we selected in the study. And as we can see, the foundry sands retrieved from the automotive manufacturing process make up more than 2/3, more than 70% of the final composition of the green mortar. And the environmental impacts associated with the proposed product was assessed using the life cycle assessment methodology. So this methodology, LCA, is increasingly adopted for supporting decision-making in the design of buildings and infrastructures. And in this study, the LCA was adopted to understand the economic and environmental profiles of the green mortar, comparing them to those of the traditional product, the traditional mortar. So in this picture, you can see the processes investigated in this study. On the top, you see the production process of the traditional mortar, and on the bottom, the production process of the green mortar. And the dotted lines that you can see define the system boundaries for the LCA developed with the SeaBubble software, as required by international regulations. So specifically, the production process of the green mortar does not include the processes required to produce the foundry scent arriving at the automotive company. The primary data for the LCA analysis, for example, data available on site, were obtained from interviews, investigations, technical inspections performed in the production sites. And the car manufacturer provided the data related to the foundry scents and to motor manufacturing processes, while the producer of the chemical product for construction provided the data related to the traditional and the green mortar production processes. For example, the cost of materials, equipment, energy consumption, material extraction, material processing, road transport, material handling. And in this table that you can see in the first part of the slide, you can see the sub-processes and the functional units that we considered in the environmental impact analysis. While secondary data, for example, data related to inert material processing, were obtained from the EcoInvent database and from the environmental product declaration. We adopted the Recipe midpoint methodology and the OpenLCA software for assessing the environmental impact. And secondly, we performed the cost-benefit analysis, namely CBA, aimed at quantifying the economic and social impact of the project, so showing the cost effectiveness in terms of obtained benefits and accessory costs. So the benefit considered in the CBA were not limited to monetary incomes, because in the study, resource savings due to mortar production processes were considered as benefits for the analysis. And as well as resource consumptions were considered as system costs. So the results of the CBA supported the investigation of the cost effectiveness of the green mortar production process and the analysis of potential economic advantages over the traditional process. So in this picture, in this table, we can see the results of the environmental impact analysis, which confirmed the positive impact of the green mortar for 17 out of 18 impact categories in the Recipe methodology. So specifically, the greatest advantages due to the use of recycled products for mortar production are on freshwater ecotoxicity and on marine ecotoxicity, while minor advantages were for natural land transformation and agricultural land occupation. While the environmental advantage due to the use of the traditional mortar, so the traditional product, is limited to the impact on urban land occupation. And we can say that the lack of a filler product in the green mortar impacts on these results. In fact, the total amount of aggregates in both the mortar is nearly 88%, but the percentage of scent in the green mortar is higher than in the traditional mortar. So the results of the LCA reveal that highest negative environmental impacts are for processes required for cement production and energy consumption due to the mortar production. So specifically, the cement production revealed the negative impact of the mortar production processes for 7 out of 18 impact categories, where 9 were for the green mortar production. And in fact, cement production requires material and energy intensive processes. While sand washing causes a negative environmental impact on 15 impact categories because of the use of both electricity in both the processes, the traditional mortar production process and the green mortar production process. So in general, the comparison between the two production processes reveals strong analogies in terms of impact categories determining the negative environmental impact, because both the processes use electricity, methane, plastics, but the seriousness of the impact depends on the presence of different aggregates in the production processes. So the lack of filler, the use of oil, and the foundry sand transport in the green mortar production process cause additional differences between the two processes. But however, we can say that the adoption of recycled aggregates in the green mortar allows greater environmental benefits. So in this table, we can see the cost distributions obtained from the CBA for the two processes, and research show that the economic advantage of the traditional mortar is actually over the green mortar. And the total cost of sand used to produce the traditional mortar includes the cost of materials, machinery, energy deployed for sand extraction, washing, processing. And similarly, the cost of the foundry sand for the green mortar includes the cost for sand transport and disposal. The cost, for example, for the fine sand, the cost for the sand transport from the automotive company to the chemical producer. So approaching the final results and the conclusions of the study, we can see that the use of the foundry sand waste produced in the automotive company would allow the production of about 1,500 tons per year of green mortar and a total cost of nearly 81,000 euros. So just to give you some numbers, in 2016, the construction material producer involved in this study produced 23,600 tons of traditional mortar, with a total cost of nearly 1.2 million euros. And the partial replacement of the sand in the mortar with the foundry waste from the automotive company would cost nearly 6,000 euros. So the cost for the transport of the foundry sand from the automotive company to the construction material producer has high impact on the total cost for the sands in the green mortar. And this cost is borne by the construction material producer. And the automotive company benefits from the economic advantage due to the elimination of the cost for the foundry waste transport and the disposal. So in conclusion, the cost-benefit analysis revealed that the green mortar supply chain confirms the overall positive balance and the economic benefits for the automotive company over the cost borne by the mortar produced. So in light of these results, we can draw some conclusions. In the last decades, we know that the overexploitation of natural resources required to reach the goals of economic progress has produced negative effects on the environment, causing the reduction of these resources and the increase in the cost of construction materials. So the necessity to reduce the use of natural resources and the increasing attention of the socio-economic systems on sustainable development are driving the transition of an increasing number of construction industries toward a sustainable business model. And the traditional approach to production, consume, disposal does not meet the requirements of sustainability, because sustainable organizations are transitioning to a circular economy model, adopting the business model of reduce, reuse, recycle to produce sustainable innovation. And in this context, the present research aims to extend the life cycle of the downstream product of a manufacturing process in a circular economy perspective. So the foundry sands from an automotive company were adopted in the production process of a high-quality green mortar for construction. And the first goal was to verify the economic and environmental benefits of the circular production model for the production of green mortar over the traditional production process. So the results of the LCA analysis proved the positive impact on the environment of the green mortar production process, which is due to the adoption of recycled aggregates for the production of the green mortar. And the second goal was to assess the economic impact of the mortar production processes, and the CBA analysis revealed the higher cost of the green mortar compared with the cost for the production of the traditional mortar, but the cost difference is due to the cost of the inert material adopted to produce the green mortar. So the transport of the foundry sand from the automotive company to the construction material producer has a high impact on the final cost of the green mortar, and this cost would be borne by the construction material producer. But however, the automotive company benefits from the economic advantage due to the elimination of the cost for the foundry waste transport and disposal. So finally, the cost-benefit analysis confirms the overall positive balance on the green mortar supply chain. And future developments of this study will investigate the use of different fine sands to produce the green mortar and the environmental impact of the production processes. Thank you very much indeed for your kind attention.
Thank you very much for the presentation. And now the floor is open for questions. Any questions, please? I wonder that you have made an excellent example for analyzing the benefits of recycling for a given step from automatic or auto production to the construction. And do you have any ideas where this can be used in for the construction industry? And the second, that we are just going to have a lot of electric cars with a lot of lithium batteries. It definitely needs recycling because lithium is now not very, how to say, easily available on the earth. So do you have any ideas then? How could be that be, how to say, rationalized and more environmental friendly?
Yeah. Two interesting observations and questions, and I will answer you with two answers. Two different answers. Well, the first about the construction industry, I just want to give you a brief insight about the context in which the research was developed. We are in the Motor Valley, and the Motor Valley is an area in northern Italy where we have important companies, leaders in car and motorbike manufacturing. We have, for example, Ferrari, Lamborghini for sportive car, Maserati, Ducati. So we have great presence of this kind of activities involving the production of foundry waste. And at the same time, we have a strong industry in ceramic. We have Marazzi Group, Panaria. We have the leaders in the production of chemicals for construction, so like Mapei, Caracol. So with this research, we wanted to create a network between the needs of these different industries, strong industries with lots of connection with small companies that work for them as suppliers for mechanical components, suppliers for materials. So our aim is to increase the supply chain, the actors in the supply chain that we have analyzed, and to try to let people, stakeholders understand the benefits of a network like this, because we could spread the cost and the benefits that I highlighted in my presentation. So we think that the potential is really high for the construction industry. While thinking about the production of other waste from, for example, electrical vehicles, as you mentioned, batteries, lithium batteries, we are working as well on this kind of waste product that are expected to large increase in the next years, both from lithium batteries from personal computers, for example, and for vehicles. And we are starting a project on the recovery of these batteries for a second life, specifically for hand bikes, for disabled persons. So the aim is to involve people in the recovery of the batteries, specifically disabled people from association that provide manual work for these people, and to recover these batteries for a second use in hand bikes with the battery. So this is another project that we are about to start.
We have still more time for one question. Abdelrazak Bokuri has a question for you. Please switch on your mic.
Okay, thank you for your presentation. So this is an excellent topic, very innovative topic. I have a couple of questions. First one is about the word that you have used, green mortar. Why you are using this word green? Because for me the processes involve so many, I don't know, chemical based and stuff to fabricate, to go from sand to this mortar. So why do you think this is a mortar, actually a green mortar? Why green?
Thank you for your question. Yes, it's an interesting question. Yeah, sure. We thought about the concept of green because we recognize the positive environmental impact of the process for the production of the green mortar over the production of traditional mortar. Because we are using, with this green mortar, we are allowing the use of less natural resources, and we are replacing the natural resources that you would use for the production of traditional mortar with something that is actually a waste, because the foundry sense of the industrial process that happens in the manufacturing company, the automotive company, is waste that should be disposed. So the manufacturing company actually pays for the retrieval of the waste and the treatment, the disposal in landfills. And the use of this foundry waste would replace the natural resources required for the production of the traditional mortar, which becomes greener because the impact of this mortar on the environment, as we proved with the LCA analysis, is really limited compared with traditional processes. That's why our research team, but together with the other partners in the project, choose this word, green.
All right, but for mass production, for example, this mortar, maybe you need to look for other sources for the material. As you said, you need sand. Like, do you have an idea from where you are going to get the sand in case of mass production and a big demand of this mortar?
Well, we actually have to firstly understand how much of such waste we can retrieve from, as I said before, from our territory, because we have a lot of companies which produce this kind of waste. So as soon as we can understand how much is the quantity of this foundry waste that we can retrieve, then we can understand how we can impact on the replacement of traditional resources for the production of traditional mortar.
Thank you so much.
Okay.
Thank you very much.
Time is going and we have to finish. Probably we can continue somewhere else. So thank you very much, Lucia. It was very interesting.
Thank you.
And looking forward to get the next results. And now we have the next paper, which will also speaking about the greener Europe, the Rotterdam SeaBubble waterline by Miguel. Please, Miguel, introduce yourself.
Thank you, Mr. Chairman. Yeah, my name is Miguel Mota. I'm associate professor at the Amsterdam University of Applied Sciences in the Department of the Aviation Academy. I'm doing research applying simulation, optimization, and other techniques to solving mainly transport problems. So if Vittorio could help me making the presentation, because I have my partner here. I have to take her today, sorry.
Yeah, of course.
I can see your co-presenter as well. Congratulations. Okay, looking for the videos.
Please remember.
It's number 99.
Oh, perfect. I'm sharing my screen.
That's it, yeah.
Okay.
Hello, this is the article towards a greener Europe analysis of the SeaBubble waterline in Rotterdam. My name is Miguel Mota. I'm the associate professor at the Amsterdam University of Applied Sciences and scientific director of the IGANT group focused on transport analysis. This work is done in collaboration with Maurice van der Mech from the company Transex. So I'm going to present this article following first an introduction, then how do we approach the problem, and then what will be the main findings and conclusions. So as the title mentions, it's a study done in Rotterdam, which is a big city in the Netherlands. The Rotterdam is located just next to the river and is connected to a waterway network in which there are small populations and cities where there is demand of people to transport from those locations to Rotterdam. The main problem is that
Something happened with the voice with me.
And they have a fixed capacity and they work on a schedule. So the main
Okay.
problem is that they are polluting with noise, with emissions, and also they are not as efficient in terms of the financial operation as it could be, because since they have fixed capacity, they have big capacity, and sometimes due to the low demand, flow season or weekends, they operate less than half empty sometimes. So it makes a costly operation for the government and also for the population, because it's public money. So the proposal of a company, or the new proposal, is to replace some of the less demanding lines with this type of vehicle, which is called the SeaBubbles. It's an electric vehicle, smaller, which can transport from 5 to 12 people, depending on the model of the vehicle, in a very efficient way. So without creating waves, without making almost zero noise, and without emitting. It's based on the principle of hydrofoiling. So it's it seems like a promising option for solving this or replacing this type of vehicles. So the way we approach to this situation is by doing a simulation of the current system. Yeah, following this methodology in which we utilize a multi-layer simulation, following the methodology of that was developed some time ago, in which we conceptualize the system. Then we create the experimental designs to identify some KPIs and analyze them. And in this particular case, we create one layer of the physical conditions, then another layer of the simulation of the network of the system, and then the main experiment that we try to understand here, or the impact we try to understand, is what would happen if we replace some of the demand that is based on the schedule into a system which is an on-demand basis using this fleet of bubbles. So as you can see in the next video that we use for presenting the results. So basically, we analyze or try to analyze this replacement of some locations that has very low demand with this SeaBubble, and we implemented following the methodology that I mentioned. This is just an animation of some of the simulations we run. For instance, line 22, it was on a schedule that we replaced it to be on demand. Yeah, and originally there was a network of 5 lines. In this case, line number 20 has the biggest demand, and we proposed, or it was proposed basically, that the ferries, the original ferries, will continue transporting people in line number 20 on a scheduled basis, but the other lines will be merged and replaced by a fleet of these SeaBubbles that will transport people on demand, and also using an app in which the people can just request the transport service from the bubbles, and they can come and pick people up and take them to their destination. So it was an interesting case in which we applied the simulation to identify what would be the impact of that implementation. So as you can see, this is line 20, and the ferries continue transporting, in this case, at the speeds of 37 kilometers, while the SeaBubble is an on-demand in other locations, but they are faster because they can achieve speeds of 37 and 45 kilometers, if I'm correct. We will see it in the next slide. So we evaluated different KPIs, for instance, the emissions and the number of passengers transported by the vehicles. So we can, in that way, identify what is the capacity achieved, and these are the speeds of the bubbles. Yes. So what also can be said is that by studying the load factors, there is a direct connection with the financial efficiency of the system. So if we have a higher load factor, it means that the cost is spread over the passengers that use the system, right? So the desirable or the most desirable situation is when we have it at full capacity. So we obtain the following results based on the peak time. And in this case, you can see, for instance, that the ride durations for the passengers were reduced in comparison to in this case, the blue lines refer to the schedule line, to the line 20, and the other is the on-demand basis. And the orange ones are for the different fleets. You can see on the vertical side the different fleets that we tested, and we identified that, for instance, some fleet like fleet A was the fastest one. Yes, and then, for instance, that was one of the indicators. Yeah, the average ride time. Then the important factor also to consider is the load factor, as I mentioned, and these are the different fleets. The blue ones refer to the ferries, and the orange ones to the SeaBubbles. You can see that the load factors in some of the fleets are not, in most of the cases, the load factors are higher in the orange ones. But in the case of fleet A, which is the most efficient fleet we could identify so far, the load factors were very high, like 90%, while the load factors of the ferries were approximately 40%. So there is an improvement in comparison with the ferries. So on the weekends is even more drastic. On the weekends, when there is very few people, we can see that the orange lines, which are the bubbles, surpass in most of the configurations of the fleets that we evaluated the ferry load factor. So it's more efficient. And related to the emissions, of course, the emissions, as you can see in this previous graph, I will go back to it. This previous one, we see that the base case, the orange one, was the original emissions of the previous lines, and when we replace it with the bubbles, then this amount of tons per week, which is 8.4 tons of CO2, are removed. So we save 8.4 tons of emissions in 1 week using this thing. And regarding to the operational costs, of course, it's an optimization problem with which we have different costs, and in particular of the fleet, what we call it A, is the most efficient one in terms also on the cost of the operation. So regarding the cost of the week, in the low season and weekends, the fleet A is the most efficient one and is better than the base case solution or the base case. So these were the main findings for this research. If you have some questions, please feel free to ask. And if not, just check the paper and there are all the details there. That's all from my side. I hope you have found it interesting. Thank you very much.
Thank you. And it's very interesting. And I have asking for questions of the floor. Anybody has any questions to that? We had such kind of connections, this kind of, we call it the flying boats, because they are on the wings between Vienna and Budapest, and it was very successful. My first question is that I would not questioning a remark better than it's very interesting. They are using, of course, actual requests and actual usage of these existing boats, and you calculate how it would be cheaper to solve the problems with this new set of new boats. But as you will introduce these new boats, then the people will behave differently. So if they have better possibilities to travel, then they change the habits, and maybe the request would be different. And it would be very interesting how this thing is changing your calculations. Have been thinking about that?
Yes, yes. Thank you very much, Janos. Yeah, we consider it because we had real data from the current company, which is called WaterBus. And the demand during the weekdays, basically people that has to go to Rotterdam to work. So we expect that in the future, this demand will stay because it's a necessity to travel from their locations to Rotterdam back and forth during the weekdays. And for the weekends, that's a different situation. Also, the low season, but it was based, as I mentioned, on a card in which the people just check in and check out. So we had all the information for that. What I would say now after the pandemic, it might be interesting, because this study was done before the pandemic. So now with the evolution of digitalization, probably this demand will change as people could work more time from home. I hope I answered your question.
It's okay, but of course everybody has to go work. But let's say now probably a lot of people using cars to go to Rotterdam because they found it more, how to say, more convenient. But if you provide a better service, a quicker service, a more convenient service, then maybe those people using now cars will go to the boat load stations and using the boats. Yes?
Yes, that's correct. That's exactly the point of this system, that in comparison to the original ferries, these two vehicles that they propose, one is bigger than the other. Both are faster. So the idea is that it's a system which is in which, as I mentioned in the video, people can call them by an app requesting a transport service, and they will be faster in Rotterdam or in other cities than waiting for the ferry. So we expect that at least the demand will be the same, or even more if some people just identify that it's nicer to use those bubbles than using the road transport, because the system there, as there are many waterways, the road connections takes much more time because they need to look for bridges and stuff like that. No, the road is bigger than the waterline.
Another thing, this is the last one. I don't want to make your co-speaker to wait too long. So, and the next one, that my experience was with these flying boats in Budapest and even on the seaside, that they are very sensitive to the waves of the water. But of course, these water lines probably have no significant waves on it. But how is it with the wind? Because they are also sensitive. If it is high winds, they just cannot raise out of the water. They should swim in that time. Have you any experience on that?
That's a good point, because regarding the waves, one of the problems with the ferries is that they created big waves, and basically they move all the garbage and all the stuff to the edges of the river, making it very badly kind of polluting, no? And then regarding the wind, I don't remember we considered that, but it might be interesting. I suppose the designers, they already thought about that.
Okay, thank you very much. Anyway, the time is out. It was very interesting presentations. I wish you good luck and a good investor to evaluate your, your dreams.
Thank you very much.
And now we have to move to the last speaker. Kathrin Kefer is here with us, and she's going to speak about optimization of complex thermally electrically coupled buildings using genetic programming to identify optimal energy flow controllers. So Kathrin, please introduce yourself, and probably then we can start the video.
Yeah, thanks a lot for the invitation. As mentioned, I'm Kathrin Kefer from Upper Austria. I am currently employed at Fronius International GmbH, which is quite a big welding and solar energy company. And that's where also my research comes from, basically from their or a research project where we did some energy management systems for residential buildings. And that was one output of the research from that. So Vittorio, may I ask you to share my video too? It's number 109.
Okay, yeah, so good. I'm sharing my screen. Is this right?
Yeah, that's the right
Yes.
one. Perfect.
Okay, let's go.
Welcome to my presentation on the optimization of complex thermally electrically coupled buildings using genetic programming to identify optimal energy flow controllers. So just a short introduction about myself. My name is Kathrin Kefer. I'm employed at Fronius International GmbH in Austria as a technical employee and PhD student. My research focus is currently on energy management systems and in more specific genetic programming and simulation-based optimizations. So as all of you know, the usage of renewable energy sources is increasing remarkably during the last few years. And therefore, the efficient and intelligent usage of such energy sources becomes more and more important. However, existing solutions are usually not optimal. So either they have a very high computational effort, like for example, model predictive controls, or they cannot produce optimal results and controls, like for example, simple rule-based systems. So we had the goal, therefore, to develop two energy management systems for a complex thermally electrically coupled system in simulation. So the two optimization approaches that we chose and developed were a linear model predictive controller as well as a heuristic optimization approach based on genetic programming. And for both energy management systems, a detailed simulation model was needed. So that's why we built up the following simulation model. What you can see here is the electric part of the system with the inverter block and the battery storage, together with the ohm pilot, which is basically a device that turns electrical energy into hot water using heating rods. And for the heuristic optimization approach, we also here added two different controllers, which each calculate the set point for the respective device. So the inverter controller tells the inverter how much energy it should charge or discharge to or from the battery, and the ohm pilot how much energy it has available to heat up the hot water boiler of the system. On the thermal side, you can see here the just mentioned hot water boiler with the heating rods and the signal from there, and the oil heating as a backup heating source for the system, and this hot water boiler then supplies the building together with the space heating control and the space heating pump. Also on the thermal side, we have here one heuristic controller, which basically controls the return flow mixer based on the available storage temperatures. So for the genetic programming approach, this works as follows. So first of all, HeuristicLab sends a command for transforming the model into C code to MATLAB. So and MATLAB then produces the C code from the Simulink model. HeuristicLab then extends this C code with further functionality and then compiles it into a DLL. And this DLL is then used during the actual training of the controllers and actual optimization approach. So there, HeuristicLab generates the new solution candidates and possible controllers in form of symbolic regression trees, injects these trees into the DLL using a so-called model wrapper, and then runs the DLL with the respective controller to calculate the simulation result. And this simulation result are basically the energy costs, which are then finally extracted from the DLL again and are then used by HeuristicLab to further improve the symbolic regression trees and solution candidates. So for the linear model predictive control, we decided to avoid mixed integer variables just because they didn't guarantee any convergence of the optimization. Despite that, we used a 24-hour prediction horizon with a 15-minute optimization interval. As cost function, pretty similar to the one used for the heuristic controllers, we basically calculate the energy costs by just multiplying the energy tariffs with the energy consumed or fed into the grid. And on the right-hand side here, additionally, add just some error measurements with weighting factors to denote the difference to the optimal set points for the MPC. For the storage model, we have a 4-node finite volume model, as there are 4 heating rods built into the system. So we have the state-based system for the thermal model looking as follows. Here we have the 4 boiler temperatures, the temperature of the house, and they are calculated, of course, using the current temperatures plus factors for the energy fed into the 4 heating rods and the backup heating and the ambient temperature. So in general, we used for the evaluation artificially generated data basis, which is based on real-world measurements from Upper Austria for 1 year. And this data includes variable energy feed and consumption tariffs, as well as the household load, which is summed up with the production of 50 kilowatt peak hydroelectric power plant, and the PV production, the PV voltage, and the weather data of the system. So for the heuristic optimization, we in total trained 10 heuristic controllers with the first day of the data basis with 2 different genetic algorithms. And the algorithms were configured to have a maximum of 100 generations with 250,000 evaluated solutions, a population size of 500 and 1,000 selected parents, a mutation probability of 30%, and for the OSGA agenda-specific selection, and for the NSGA2 a crowded tournament selection. So the evaluation process works as follows. The simulation model is run with an interval of 1 second and an initial state of charge of the battery of 30%. And with that, each energy flow management, or basically each controller, is simulated for 30, 60, 180, and 364 days, starting on the 2nd day of the database, is basically the day after the training day for the heuristic controllers. The results of the simulation, as already mentioned, are the energy costs of the system in euro. And we use this energy costs to compare the different controllers, like the linear MPC, the 10 heuristic controllers, and in addition to that, as some sort of baseline model, a simple rule-based self-consumption optimization. So what you can see here are the energy costs for the different simulation time spans and each optimizer. So up to 180 days, it seems that the heuristic controllers, so the 5 NSGA2 and the 5 OSGA algorithms, here perform better than both other algorithms, like the model predictive control and the self-consumption optimization. But however, when running the simulation for 364 days, this just turns around, and the self-consumption optimization and model predictive control now seem to work better than the heuristic controllers. However, we couldn't prove any statistical significance there concerning the differences. What you can see here in the graphics is basically also just the energy costs plotted over the whole 364 days of evaluation on the left-hand side. And what you can see here is exactly what is also denoted in the numbers. The self-consumption optimization and the linear model predictive control, especially here, beginning of summer and during the summertime, perform worse than the heuristic controllers. But however, here on the right-hand side, which is also extracted on the right-hand side here, there is a turnover point between 180 and 364 days, so that the self-consumption optimization and the model predictive control then start outperforming the 10 heuristic controllers by just needing less energy costs than they do after all. So thanks for your attention, and if there are any questions, I'm happy to answer them, or you can also, of course, just refer to the paper. Thanks.
Thank you very much, but we have some time for some questions. Please raise your hands if you want to talk to the author. I have an interesting idea that in some cases it was in Australia, they are not heating houses, but the whole energy of the small community is controlled. That on the basis of the experience, if you could use some not predicting models, weather forecasts for the next week, that the controller should know the next week will be very cold, or just on the weekend there will be very cold, or something like that. Then these controllers could better prepare for that. That means keeping more energy just to prepare to survive the weekend. Have you this kind of ideas about it? Okay, then we cannot hear anything. You can. Are you switching on? The microphone is not switched on. Please, you cannot switch on the microphone. So, unfortunately, anyway, that would be very interesting, but maybe the next time. Those techniques, better to be personally, you know. And then we have even more questions when we have the coffee break. So thank you very much then again. And thank you for our participants. And the techniques are still not how to say, promising, but and thank you for Vittorio helping us out with these videos. Without Vittorio, there would be no session at all. So thank you very much, and see you on the next session if you come. And have a nice time. And that's the end of it. Thank you.
Thank you.